All right, guys, in this video, we are going to talk about the rest of section 3.1 or the topic 2.1, however you're looking at the way this is labeled. So we're going to talk about geometric sequences. If you missed the last video, the last one we talked about arithmetic, so definitely go watch that if you haven't. But the geometric sequences, we are working with a different pattern, but a lot of the same ideas as far as how sequences are concerned. So remember that the only inputs are going to be whole numbers, and we'll have little equations that represent these. The sequences will not be continuous, right? So you see in here, there is a difference here about the terms. Instead of the terms having a common difference, the terms will have a common ratio. So instead of like adding the same thing every single time for each number, you're going to be like multiplying by the same thing each time. That's what we're going to look for. We have a couple different formulas, but just like on the last one, we have an initial value. That's if you have that subscript 0. So that's G sub 0 since we're working with geometric, right? But that is the initial value. R here is the common ratio. And then we have this G sub K, which just like on the last thing, this is that kth term. Okay, now instead of having a linear relationship, geometric sequences are going to show an exponential type of relationship. So if you remember what exponential looks like, that's that function that's kind of like curved. Okay, it may curve up or it could curve down. And that's something that we're actually going to get into shortly after this video. Okay, so this kind of leads us into that very nicely. All right, so the first example we have is asking us to do some graphing. You're going to see this. It says that we have 8 times 1/2 to the n. Now you can refer back to, it's that simplified form of the equation here. So that 8 is talking about like the initial value. 1/2 is going to be your rate, okay, or your ratio. And so you can do it that way, but you can also make a table of values, which is what we did last time. So that's what I'm going to stick with here. But once you really get comfortable with these and how they're structured, you can kind of make a little bit of a shortcut on yourself if you recognize them giving you that simple equation with your initial value and the common ratio. But let's plug in some values. We're going to do the 0, 1, 2, 3. Start there. If we want more, we can do more. So if I plugged in a 0, anything to the 0 power is going to be 1. 1 times 8, 8. If you plug in a 1, you get 1/2 to the first power, which is 1/2 times 8 is 4. If we plug in a 2, now for those of y'all who have forgotten your exponential or your properties when you deal with exponents, when you square a fraction like that, it squares the top and squares the bottom. So this is really 8 times 1 over 4. So 8 times 1/4 would give us 2. If you did a 3 instead, 8 times 1/2 to the third, that's going to give you 8 over cube, both the top and the bottom, 1 over 8, which results in 1. And you could keep going, but I want you to see what's going on here. We went from 8 to 4 to 2 to 1, right? So each of those is getting cut in half. That's what we're talking about with this rate, or the ratio, okay? The initial value, 0, 8, right? That's your starting point. So up here we have the point 0, 8. Then we have 1, 4. We have 2, 2. 3, 1, and you could keep going and so on, okay? If you wanted to just figure out the next one, if you plugged in a 4, just cut the last number in half, it's 1/2, right? But don't connect them, right? These are going to get closer and closer to that axis down there, but not ever cross it. There's an asymptote. All right, let's see if we can figure out what represents a geometric sequence or not. So on this one, it says determine if it's a geometric sequence. If so, we're going to tell the common ratio. So on this guy, I can look at it, and with a practice die, you can say, I can tell it's not 1, but that's because I know it's not exponential. the variable is not the exponent, right? But what we're going to do here, we're going to make ourselves a little table again, just so that you can stay consistent. If we plug in these values, plug in a 0, well, that would be raising 0 to the second power. That is 0 times 3, 0. Plug in a 1, 1 squared is 1, times 3, 3. 2 squared is 4, times 3, 12. Plug in a 3, 3 squared is 9, times 3, 27. If you try to find a pattern as to what you can multiply by to get the next term here, you can't multiply 0 times anything to get 3, right? 3 times 4 would be 12, but if I try to multiply times 4 again, I don't get 27. There is no, it's not a geometric sequence because there's no common ratio. Okay, not a geometric sequence because there's no common ratio. All right, look at the next one. The next one, we're going to do the same deal. We're going to put an n, g sub n. Okay, we plug these in. Now, this one might be a little bit more tricky. I'm going to pull something over here just for some scratch work. Okay, here's a little sticky note here, so I'm not writing all over my notes. But you may have a harder time doing this one in your head. So I'm going to bring this over here. 4 times 2, and if we plug in a 0, right? Well, if I plug in a 0, 0 minus 1 is a negative 1. 2 to the negative first is going to be the same thing as 1 over 2 to the first, right? Negative exponents, flip it, and bring that number down to the denominator. 4 times a half is going to give us 2. All right, I plug in another number. If we plug it in, I'm going to come down here. Let's plug in a 1. 1 minus 1. Well, 1 minus 1 is 1, so this is 4. Sorry, 1 minus 1 is 0. So this is 1/2 to the 0 power, which is 1. 4 times 1, 4. Okay. I'm going to keep doing that a little bit over here. We've got 4 times 2 to the 2 minus 1. Well, 2 minus 1 is 1. So this is 4 times 2 to the first, which is going to give us 8. We're going to do 4 times 2 to the 3 minus 1. 3 minus 1 is 2. So 2 squared. This is 4 times 4, which is 16. Okay? And we could keep going, but what I want us to look at is the pattern here. So I'm going to get rid of my scratch paper there. But anyways, we're going from 2 to 4 to 8 to 16. And some of y'all are already like, I see the pattern. From 2 to 4, they multiplied times 2. 4 to 8 is times 2. 8 to 16 times 2. So, yes, this is a geometric sequence, and that common ratio is 2. Next one, we're going to check and see what kind of pattern there is, and we're going to look for a multiplicative pattern because that is what they've asked. They said, is it geometric? Okay. So, from 1 to 3, you could have multiplied by 3. Right? 1 times 3 is 3. But you can't multiply times 3 to get 2. You look here, if you were trying to figure out what you would have multiplied by to go from 3 to 2, it would have been times 2/3. You can, another trick to kind of figure out what the ratio is between the two of them is just make a fraction, the second number divided by the previous number. Like over here, 6 divided by 2 is 3. They multiplied times 3. But then 6 to 4, that was 4 over 6, which reduces to 2/3. So what I want us to see here is there is kind of a pattern. They're flip-flopping between multiplying by 3 or multiplying by 2/3. But that is not a geometric sequence. It's not common. It's not constant. Okay, so we have to have the same ratio the whole time. So no, because there is no common ratio. All right, we got one more. This one's a little bit weirder looking. Some of y'all may be looking at it and you're like, immediately you see what's going on. But from 16 to negative 8, we have to think about what they would have multiplied by. Well, they cut it in half. 16 divided by 2 is 8. But they didn't just cut it in half. They also changed the sign, which means that what they multiplied by was a negative 1/2 to change that sign. Again, you could have done this by putting a negative 8 over 16 and reduce it. It would come out as negative 1/2. Well, from a -8 to a +4, again, it was cut in half and the sign changed. So same thing, they multiplied by a -1/2. Again, you could have done this by saying 4 over a -8. Reduce that down, it would give you that -1/2. But each one of these is getting multiplied by a -1/2. So there is your constant ratio. Okay. Yes, this is a geometric sequence. So we'll say yes. And that R is -1/2. Right? Okay. Next problem. I gotta put a little line here. This graph is meant for the problem below it. I don't know why it's structured this way. It throws me off every time I look at it. So the top question, number 7, and then we'll deal with the one with the graph. It's actually for number 8. So number 7, it says, let G sub n be a geometric sequence with G sub 1 is 12, R equals 2. Find an expression for G sub n and use the expression to find G sub 4. So I'm going to be referencing back to these equations. Maybe write them down somewhere or just make sure that you know what I'm pulling from. But I'm going to be pulling from these 2 equations for various problems to decide what type of or what would be the easiest way to write the equation. So we're going to pull from either or, and honestly, you can kind of use either one just depending on how you're feeling. I have used them interchangeably more times than I can count. So I would not stress over saying you have to use this one for this circumstance. You kind of can deviate if you do things properly. Okay. But something that I see here is we've been given one term and the common ratio. For me, most of the time, if I've got like 2 terms, that's when I'm going to switch to using this one down here because it works with a G sub n and a G sub k. And otherwise, I'm going to try to stick with the cleaner one that's up there. So anyways, that's what I'm going to try to do, but you can kind of deviate from that if you wish, okay? So because I've only been given one term on this, I am going to stick with that first equation. I'm going to write that down right here. The G sub n equals G sub 0 R to the n. Gorn. All right. So now keep in mind, they did not give me the initial value. So that's something I am going to have to solve for here because I don't have it. I do have a random term. So we have this guy right here. And for the purpose of this problem, I'm going to let this little subscript be the n so that we can represent this as G sub n. Okay. So I'm going to let G sub 1, I'm going to let that be G sub n. So G sub n is 12. So n is 1, G sub n is 12. I'm going to zoom in a little bit so you can see maybe a little better, okay? They've also told me that the ratio is 2. And so what we can do is we can actually solve for that initial value. We did stuff like this on the last video with the arithmetic. But I can plug these in and solve for the initial value so I can write the expression really nicely. So if I plug this in, I would have 12 equals, we don't know, G sub n, times my rate, or my ratio, which is 2. And then that's going to be raised to the first power. Well, 2 to the first is just 2. And if you divide both sides by 2, you get 6 for that initial value. Okay. So right there, I've got that. I can write the expression really nice, but I need to go back and put the n's in place. Okay. We know that the ratio is going to be 2 and to the nth. So that's probably the cleanest way to write the equation. It's not the only way to do it because if I had chosen to use the other one, instead of the simple one, if I'd chosen to use the other, it just would have been a little bit of an uglier equation. However, you still will get the same answer when we plug in the 4. So let's do that part. They said find G sub 4. 6 times 2 to the 4th power. 2 to the 4th is going to be, what? 2 times 2 is 4 times 2 is 8 times 2 is 16. This is 6 times 16. Which will be 96. So, yay. Got our equation, got our answer. All right, I've had a lot of questions about the whole graphing thing, so let's make sure that we can read these graphs. Okay, so on this one, they've given us a graph, and then they didn't really give much more information in the problem other than saying that it's representing a geometric sequence and tell us to find an expression for g sub n and write out find whatever g sub 10 would be. So what we're going to do here is try to figure out what's the pattern that's going on. Something I would like to do is maybe represent these terms. Well, this is the initial term at g sub 0, and that's at 8. This guy would be g sub 1, and that's at the value 4. This is g sub 2, and it is at 2. G sub 3 is at 1. And these other ones, I could start making little inferences or assumptions, but I'm going to, because they're fractional, avoid that for a moment and look at the ones that are a little bit more obvious. We went from 8 to 4 to 2 to 1. Well, most of y'all would recognize that what they've done here is they've cut it in half every single time. From 8 to 4, it's like they divided by 2, so times 1/2. 4 to 2, they cut it in half again, so times 1/2. 2 to 1, they cut it in half, right? So because of that, we know that our common ratio is going to be 1/2, and then you can write out the problem. All right, now I've also been told not only have I very easily gotten what the common ratio is, but I know what the initial value is because of the way that this was structured. So because I do know that, I'm going to use that to my advantage. Otherwise, I would have to just treat it like I had two separate terms and maybe use that second equation and plug things in, okay? But because I do have the initial, then I'm going to work with that, okay? Now, say that you're working a problem and you don't have the initial one. If you have to pick two different terms on here, it does matter which one is the n and which one is the k. So make sure that you stay tuned for the next couple problems to be able to do that, okay? So here it says we need to write an expression for g sub n. So I am going to use that simple one. G sub n equals your initial times my ratio to the nth power. Okay, Gorn. Well, I know that my initial value is 8. So we're going to say g sub n equals 8. My rate we just found was 1/2. And so there's your little equation. And I need to plug in a 10. G sub 10 would be 8 times 1/2 to the 10th power. And just to save us some time here, I've gone ahead and worked it out. This was 1 over 1024. And if you multiply it, you end up getting 1 over 128 when it's simplified, okay? So I would go with a simplified fraction rather than a decimal on this. Okay, we're going to do one more example. So we're going to flip to the back here. And the main reason is because if they give us a slightly different scenario, this is what I was just saying with the last thing. If they give you a different scenario where you have two terms, it actually does matter which of the terms is which one is your n and which one is your k. Okay, so the easiest way to know, they said use both terms to create one equation in general form. Use the larger k value term as the g sub n term. What they're meaning is use the larger subscript. Okay, so find the larger subscript. That's what we mean by that. Otherwise, it's really just plugging into that formula the way that it was written out, okay? So we're going to do example 3. Now, I know you can't see. Let's see if I can zoom out a little bit more. I just don't want it to be too little. They said let G sub n be a geometric sequence. G sub 3 is -2, and G sub 6 is 128. They said find an expression for G sub n and all that jazz. So we're going to find the larger subscript, okay? Not the larger output, the larger subscript, okay? So sometimes that's different. Don't just assume that it's always going to be the same. So we're going to look at our little subscripts. We have a 3 and a 6. The larger subscript is going to be the n term. So n is going to be 6. And then everything else should fall into place. So I've decided that n is 6. That means that this value is g sub n. Okay, if that was the n's, this one's going to be the k's. For the purpose of that equation, this is g sub k. Okay, so we're going to use that a little bit more complex equation that has the k's in it as well. I'm going to rewrite that out here just so we have it, but it is g sub n equals g sub k times your common ratio to the n minus k power. Okay, so we're going to plug in these values and figure out what that common ratio is, because that's something I'm missing and it is a key piece. Okay, so I'm going to plug everything in. We have 4 values here. We're going to plug in g sub n, which is 128. G sub k is a -2. We don't know r, but we said n was 6 and k is 3. So we're able to go on a little journey here to find what the ratio would be. So if I divide by -2, that's going to cancel. Okay. I know I don't always show that little stat, but here I have a -64 equals r to the 6 minus 3 third power. In order to figure out my r, we are going to have to cube root so that that cancels out. And the cube root of a negative does work. You get a -4 for the r value. Okay. Now, in order to write the expression for g sub n, guys, you have 2 options. You can either go on a journey, now that we know r, you can go on a journey to figure out what the initial value was and then use that simple equation to write it. But honestly, at this point, I could just go back and use this equation and make it simpler on myself. If we do that, all I'm going to do is put the n's back in place and plug in values for the k's and for the r. Okay, so I'm going to use g sub n instead of using 128, but g sub k, I am going to leave that as a number. We found the ratio was -4. This is going to be the n minus the k value. So again, like I said, just put the n's back in place, plug in all the k's and the r's. This is an equation. It is not the only one. So remember, if you had decided to go and use that other equation and get your initial value and write that one out, then that would also have worked and been fine. So you can have multiple different answers. Okay, so we're going to then plug in G sub, what do they want? G sub 11. That's what they asked us to find. So G sub 11. -2 times a -4 to the 11 minus 3. You can just type that in your calculator. It will do the order of operations for you. Make sure that you use the parentheses, because if you don't, you get into a different number. Okay, so please make sure the parentheses are in the problem. But this should end up coming out as a -131,072, 131,072. That would be our answer. I would not have wanted to do that by hand. So calculator is best on that type of thing when the numbers get too big. All right, guys, that is it for this video. Good luck, and I'll see y'all in the next one. Bye.